Hello friends, welcome to Joy of Life. So today we are going to look at another Leetcode problem number 91. It's also a medium level problem, decode ways. So the problem says a message containing letter from A to Z can be encoded into numbers using the following mapping. So A is 1, B is 2, C is 3, D is 4 and so on. Z is 26 up to Z is 26. To decode an encoded message, all the digits must be mapped back into letters using the reverse of the mapping. There could be multiple ways. For example, 111 can have each of its 1 be mapped to a to make it AAA, or it could be 1 1 and 1, which is like KA, and so on. So basically the problem says that we will be provided with a number and we need to find out how many ways we can decode this into. So let's take a few examples and let's try to understand the problem first before we start with the coding part. So what we'll do is we'll take some of the examples. We'll go to the whiteboard and take some of the examples and try to work on it. So first to start with is the mapping that we have. So 1 is A, 2 is B. So I'll just pause and create the entire table for you for simplicity of understanding. So I have created the table. I have mapped from 1 to 26 and A to Z along with it. And now we'll look at some of the examples and how we are going to solve it. So one example could be 111, wherein 1 is mapped to A, second one is also mapped to A, and the third one is also mapped to A. So my one answer could be AAA. Second one could be, instead of using this as a 1, I could use this as a 11. So 11 is mapped to K. So if I take 11, I have only one remaining, which could be used as A. And the third one could be, I can use this 1 as a and the next I'll take both the ones together, which will result to a K. So this could be my three options. Similarly, for a smaller number also, we can see that the same thing could happen. If I have an example like 12, so I could either say it is AB, or I could consider 12 as a whole and say that the answer is L. So now we'll go through some of the examples and try to understand how we can solution this. So we will use recursion to solve this problem. So I'll explain how recursion will help us over here. So for example, let's say I have a number like 111. So what I can do is I can use the 1. If I use this one, what will I be left with? I'll be left with 11. Or I could use the 11 and what I am left with is 1. Similarly for 11, what I can do is use the 1 or use the 11. So I'll just mark it as null over here because we have used both. So similarly for here also we have 1. So we can, I'll just put a null over here and we can use this null and we can use this one and which will lead to a null. So I have my recursion tree. So this is basically a recursion tree that we are creating. So we are trying to use 1 digit or 2 digit and then pass on the same to the same, pass on the remaining to the same function in order to come up with the result. So let's take another example before we deep dive into the solution. So let's take a complex example of 1 2 3 2 1, a bigger number. So just as I said that I can use this only one digit 1, right? If I use this one, I'll be left with 2321, right? So I will call the same function with 2 3 2 1, or I could use 12 1 2 and pass on 3 2 1 to the same function. So initially this is my input to the function, and then I'm going through a recursive approach. So I have used 1, passing on 2 3 2 1. I have used 1 2, I'm passing 3 2 3 2 1. So if you look at, we have a range which is from 1 to 26, right? So if I cannot go any further, I cannot take 1 2 3 into consideration. So this becomes my 2 input to the recursive function. So coming down to this function, what I can do is I can use 2 and pass on 3 2 1 to my recursive function, or could use 2 3 and pass on 2 1 to my recursive function, right? Similarly for this one, I could use the 3 and pass on 2 1. But if you notice here, I cannot take 3 2 because it is greater than the range. The range is from 1 to 26. So if it is greater, so I cannot use 2 digits. I have to use only 1 digit because 32 will push me out of the range. So I have 21 remaining. So this is my next level of recursion. So again from here, I could use 3 and pass on 2 1, right? I cannot use 3 2. So this tree will have only one branch. So similarly for this one, I could use 2 and pass on 1, or I could use the entire 21 and pass on nothing, right? Again from this 21, I could use 2 and pass on 2, or I could use the full 21 and pass on nothing. Similarly for here also, I could use the 2 and pass on 1, and I could pass on nothing. And again from 1 we will consume everything and pass on nothing. So this is what my entire recursion tree will look like. So here I made a mistake. We have used 2, so we'll pass on 1. So this is 1, not 2, because we have used the 2 and pass on 1. So now we take the 2 and we pass on null. So this becomes my entire recursion tree for this solution, right? So if you see at all, if you see this tree, what you will observe is we are doing few calculations over and over again, like for 3 2 1. So we are computing 3 2 1 here, and we are computing 3 2 1 over here, right? Similarly, for 21 also, you'll see that we are computing it again and again. So there is when we are using a recursive solution, it's always good that we try to find out similar patterns and try to optimize the solution. Okay, so what we are going to do, we are going to use memoization for this. So as you might already be aware that memoization is a optimization technique used to speed up the processing of the computer programs, right? So what we are going to do is when we encounter this 3 2 1 in the recursion, when we get a result over here, when we have a result over here, we are going to store the result. And when we encounter a 3 2 1, again, we are not going to recalculate the entire tree again. Rather, we will retrieve the result. So we'll be storing the result in some data structure. So the first time we do the computation, we store the result. Next time we encounter something similar, we are going to retrieve the results. So we save up the processing time. So we don't need, so it can be a very big number as well, right? When you're tested with very big inputs, this might happen that you are saving a lot of time. So for 21 also, you're seeing that we are going to compute it over here, but here we are going to retrieve it. We are just going to retrieve the result here. Here 21 will never come because 321 is already in our store, and we are going to retrieve 321 from it. So this is how we can optimize our solution. So now let's look at the code and let's see how we can use memoization and recursion in order to solve this problem. So let's go to the code. Yeah. So what we are going to store for our output is we are going to return the number of encodings that we have found. Okay, so that will be like for 111, the output would be 3. So let me go back to the drawing board again. So over here, as you can see, that we have 111. So we have 3 results: this one, and this one. So the output would be 3, and not the actual decodings, but the count of decodings, the total number of count of decodings. So let's go back to the code once again and start writing it. Yeah. So we are going to return the count. So our num decoding function will be called with the input, and we need to come up with the result. So the first thing is we need our termination condition. So when we are going to start uh, when we are going to stop the recursion. So if S is null, that is one case when we are going to stop the recursion. And there are some of the edge cases also that I want to talk about. So edge cases like there could be an input like 0, a totally invalid input. So in that case also you should terminate, or when we are passed with an empty string, or when we are given a null. So there are several edge cases that we should handle when writing the code. It should not fail in with the wrong inputs. So if S equals, so just to remind you, it's a string that we are working on. So in this case, we can say that our result is 0, right? Another case could be um, so another case could be when my string, sorry, when my string is of length 0. That is another time when we are going to stop our recursion, and we are going to say that we have found a result, right? When I have no string, so every time I am taking a digit and passing on the remaining, right? So a time will come when nothing will be passed. So basically on the whiteboard, wherever I said it's null, it's basically empty strings or null. So if you are taking the digit 1 from 1 and sending the remaining, what you are left with is a empty string. So if I have a string like 2, 1, and I am taking 2 out of it, then I have 1, right? And if I take 1 out of 1, then I have nothing but an empty string. Though I have denoted them with nulls, but those are actually empty strings that we are referring to. Okay. Now we have mentioned our termination conditions, like when our recursion should stop, the base cases you can say. Now when we receive a normal string, our first is to get the digit out of it, right? So I will get the digit. I'll just do a integer dot parse int, and I will get my input is s, and so I'll do a substring, and I need only one character from that string. So what it does is, it will, if the number is 1, 2, 3, it will give me 1. So I have 1 with me now. So now another interesting thing that might happen is you might get a 0, right? So we talked about a edge case wherein our result could be 0, right? But there could be a case wherein we have an input like 10. So we use 1 and pass on 0, right? This could also happen. So we should prevent this scenario from happening. So what we'll do is, if we see at any given point of time we see a digit is 0, then we should return 0. Means there is no other combination that there is no other decodings that I could find here. So I am returning a 0 straight away. So this is another validation that we have added. And now another thing that we are interested is in the next digit. So we have already extracted one digit. Now we are going to get the next digit, right? So I'll just initialize it with null, and then before I extract the next digit from the string, I have to see that the length of my, I have already extracted one digit, right? So I have to check if the string is long enough, if it at all has another digit present or not. So that's why I'm just doing a length check, right? The input could be simply one, right? So for example, mm, I have my input string s is 1 in quotes, yeah. So I have already uh, used digit and I have extracted out 1, and there is no next digit. So the string is empty. So that's why I am doing a length check that s the variable, its length should be greater than 1. So that is the check that we are enforcing over here. So if it has a length greater than 1, that means the next digit is present, right? So similar thing that we'll be doing, integer dot parseInt, and we'll do a substring. So last time we did the substring starting from the index 1, index 0. This time we are going to do it from index 1. So it will give me the next digit. Now we got the next digit, right? Now what we need to do is we need to check. So we need to check that this digit. So there are few conditions. So let's revisit the conditions over here. I'll just scroll out a little bit. Yeah. So if my digit is the first one, if digit is 1, then I can take any values from 0 to 9. If the digit is 2, then I can take only 1 to 6. If digit is greater than 2, then I cannot take anything. So these are my three conditions for getting the next digit, right? So you got the point, right? I have 10, 11, 12. So if you see this chart, I have all the numbers starting from 0 to 9 for by 1, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, so on, and 1 to 9. And for this one, sorry, this will be 0 to 6, not 1 to 6. And for if the digit is 2, then the only allowed values are these seven values: 20, 21, 22, 23, 24, 25, and 26. Since we don't have any characters after 26, so anything greater than 26 is invalid. So we are going to enforce that check before we go into the recursion. So what I'm going to do over here is we are going to check. So firstly, the next digit should be present, so it should not be equals to null. That's my basic check over here. And we are going to validate. So if digit is 1, I don't need to worry about anything. So I'll have another bunch of conditions with the OR. So if digit is 1, that is fine. But if digit is 2, then what I'll say is next digit should be less than 7 or less than equal to 6. So we are going to allow only when a next digit is present, or next digit should be present in order to process this. And along with that, either of these two conditions, either this or this, need to be satisfied. So what are those conditions? The first is the digit that we have, the first extraction that we did should be 1, or it can be 2. If it is 2, we have a subsequent condition, then the next digit should be less than equal to 6, so that we are protected till 20 to 26. And for 1, we have no restriction. We can take from 10 to 19, right? In this case, we are going to process it. So in this case, what will happen is I have to readjust my substring, right? Because we are considering 2 digits over here. So what I'll do is I'll do a S. So let's call it str. So we are going to do a s dot substring, and we are going to take from the second index onward. So inside we are processing the second digit as well. So let's just fall back to the whiteboard again. So in this case, say we have a number like 1, 2, 3. So if we have taken 1, 2, then in the recursion we need to pass only 3, right? And we should not pass. So here we'll have two things. So one is we use up the 1 and pass 2, 3, or we use 12 and pass 3. So we are working on the second condition at the moment. We'll soon get back to the first condition as well. So what we are doing over here is we are just taking us s dot, we're doing a s dot substring and taking from the second index onwards. We are omitting the first two characters of the string, right? And then we are going to call the the same function that we have. So we are going to call the num decodings with str. So we are passing the truncated string to the same function all over again, right? Okay, so this functions returns a value, right? So what I'll do is I'll call it as result, and we'll capture this value that we are getting into a variable called result. So it is getting me an integer. Okay, so when we are using this, what we need to do is we need to, so since it's need to be initialized, I'll initialize with 0. Okay, so now we got a result from this operations, right? So what we need to do is we talked about something called a memoization. So memoization, what we are going to do is we are going to store the result and we are going to reuse the result. So what I'll do is I will use a map. So this map will have string and a integer, and we'll call it cache. So we are going to cache our result in this, and we are going to look up to this whenever we have a input, or we are going to put a result we are whenever we are processing one of the input. So we are going, now we have a result over here. We got a result. So what we are going to do is we are going to put it back to the cache. So I'm going to, so I know I have passed str over here and I got a result. So whatever result I got, I am going to put this result into my cache. So if in future I get a request, I can look up to it. So let's put that part also over here. So whenever I get an input, so first what I'll do, I will go, and whenever I get an input, I will go and check if my cache already has this result or not. If my cache is having this result, so what I'm going to do is I am not going to process any further. I am going to return from here. So this is the optimization, memoization part that I was referring to. So whenever we are computing a result, we are going to put it to this global variable cache. And whenever we start processing any of the string, we are going to look up to the cache and see that it is present there or not. Okay. So similarly here also, if you see that here also we did a computation has ended over here. So we can put this result as well over here. So we can say that this is 1 because we know the result over here when the string has no length. So in that case, I am going to return a 1, right? And that is when I am also putting the same into the cache. Okay, so now as we just spoke that we are done with this part of the recursion. Well, we are using 2 digits, and now we are going to look at the first part of it where we are using 1 digit. So this part is not yet done. So we are going to do this part. So yeah, let's go back to the code once again. So what I am going to do is, now this part is very simple. I'll say that I am going to the value and I am calling num decodings. I am sure I'll make a typo here, so let me copy paste. So here I'll be calling num decodings with s but one character removed from the front of it, right? Because we have used one character already. So we'll do a substring and with 1. So this is going to be my result and I am going to return val, right? So this is the result of my uh, um, single character processing, and this is the result of my double character processing result and num. So basically I can say my would be what did I result? Yeah. So for simplicity, let's put it over here. So I'll just add results to the num decodings. Why I moved it up is for one reason, because here also we are getting a result inside val, right? And the result is for the string s. So we are going to put this into our cache, right? And now we are returning the the result. So here is the code. Here we have seen that how we are going to solve this problem. So let's see how this code performs. Some problem. Okay, I should use an integer. So you can see here that for 12 my output is 2 and 2. So let's do a submit and see. So you can see that our code took 7 milliseconds, and of course there are places where we can optimize, but here my main intention is to give you how to solve the problem, and I would leave the optimization part up to you. So let's look uh, with a test case that we'll provide to it. So for 1 2 3 2 1, so this is our test case that is given by us to the system, and we wanted to see at what all places we could optimize it. So we're just going to put a system.out.println to see, and we'll say serving from cache, and for s, and the result is, just wanted to see how many times it gets called. So it will give you an idea like how it is helping us. So you can see here that for 1, for 2 1, for 3 2 1, for every repetitions, it is going to the cache and returning me the result. So so for bigger inputs wherein we could have more repetitions, it could really help us in optimizing the problem. So if you see here, if I have an input like this, so you'll see a lot of data being served from the cache. So you can see that all these are already stored in cache. So these are all served from the cache. So if I remove the caching part, you will see that the performance of the code will degrade to a great extent. So here is my solution. I hope you got the solution. Do subscribe, share, and like. I'll try to share more videos in the days to come. Thank you for watching again. Have a great day. Thank you.